So here we are, example number 1, determining the tangent ratios for angles. So you have to be careful with the terminology of the questions. This question, indicated by this statement here, is just looking for the tangent ratio. Okay, it's just looking for the tangent ratio. The next step in this series of calculations would be to find the actual angle. Okay, so these are, it's a two-step question to find the angle. This is the first step. Okay? So determine tangent x and tangent z. Okay? So we just want to know the ratio from the triangle that we're given what tangent x and tangent z are. So let's start with tangent x. So here's our triangle. The first thing we need to do is recognize that if we're looking for tangent of an angle is equal to opposite over adjacent. Or in this case, tangent of x is equal to opposite over adjacent. Now we need to figure out what the opposite side is and what the adjacent side is. So we go to our picture, we look at this here. It says, well, if we're talking about and looking at angle x, that means we're looking at or referring to this angle. We need to label our triangle. This side would be the hypotenuse. The hypotenuse is always opposite to the 90-degree angle, so I spelled it wrong, hippie. Hypotenuse is always opposite to the right angle. Let's did it again. Hypotenuse is always opposite to the right angle. It's always the longest side in the triangle. Easy label to do. If this angle x is the angle we're talking about, referring to, then this side, side 6, is our opposite side. And side 12 is our adjacent side. Okay. So now we have labels. So our opposite side is side 6 and our adjacent side is side 12. We can fill in the rest of our formula. Over here, our opposite side was side 6. Our adjacent side was 12. So tangent of x is 6 over 12, or tangent of x is equal to 0.5, because we will eventually need that decimal place. So this is the final step, or the last part of this style of question. It's asking you for the ratio. What is tan x? Well, tan x, tangent x, is 0.5. Done. That's the first step in calculating an angle. The next step, we use the funky buttons on our calculator. Okay, so let's find tangent z before we move on. I'm going to switch colors. I'm going to switch color. Let's switch to blue. We go back here again. This time now, my reference angle is this angle, z. Hypotenuse still stays the same. It's still opposite to our right angle triangle. Our right angle. It's still the longest side in the triangle, so that doesn't change. But this side 12 now becomes my opposite side, and this side 6 becomes my adjacent side. So because we've switched the ratios, or not the ratio, but the angle that we're referring to, we have to switch our labels in our triangle. So now our adjacent is 6 and our opposite is 12. We go back over here, we say, well, if we're looking for tangent of some kind of angle, I know it's opposite over adjacent. I know that it's tangent, I know that I'm looking for tangent of z, which is going to still be opposite over adjacent. This time I know my angle measurement, or not my angle, my side measurements. My opposite side is 12, my adjacent side is 6, so this is going to be 12 over 6. And if I simplify that a little bit, I can say that tangent z is equal to 2. So there are my two trig ratios for tangent x and tangent z. Those are just the ratios, and that's the first step. Okay, I'll come back in the next video with the second step on calculating angles, just to make sure. Actually, you know what? I'm going to calculate the angles with this question because it goes too fast. So now that I've found the ratio, I'm going to extend this question. I'm going to extend this question and say, well, let's now calculate what angle x is. What is angle x? Okay, what is angle x? Let's do this again. This symbol means angle. Of course, that's x, and this is supposed to be a question mark. What is angle x? If I know my tangent ratio for an angle has some value, then on my handy dandy calculator, if I'm looking for an angle, I have to perform the following steps. From here I say, well, if tangent x is 0.5, then angle x has to be the inverse function of tangent minus 1 of 0.5. So on your calculator, and different calculators have different steps, you somehow have to get your calculator to say tangent minus 1, or the inverse function of tangent, of 0.5. And if you punch that into your handy dandy calculator, oh, I don't have my calculator down here with me, I can't even calculate it. Okay. You punch that into your handy dandy calculator, then you will get a value for x. Okay. Well, I got my phone calculator here. Let's see what I can do here. Portrait, landscape, inverse function of, where's the shift? Second function of 0.5 sine to the minus, no, tangent to the minus 1, 26.56, 505. Now, angle measurement. So this is calculated the angle x, the actual angle. Angle measurements can be rounded to the nearest whole number unless it tells you otherwise. So this would be 27 degrees. Okay. And if I follow those, I'm going to quickly follow the steps for the next one just so we can see it all. So this is now telling me that this angle x, it measures 27 degrees. If I quickly do this for this one, tangent z is equal to 2, then that means that angle z has to be the inverse function of 2. So inverse function of tangent of 2. So I put that in my calculator, 2, and I go second function tangent, and I get 63.4349 or 63 degrees. So now that tells me that this angle measurement is 63 degrees. So what does that mean? Does it look a little right to you or wrong? If I draw this triangle again without all my labels, I know that this angle is 90. I know that this angle we just said was 27. This angle was 63. What do all angles in a triangle have to add up to? 180 degrees. Does that add up to 180 degrees? Yes, it does. Okay. Now that was really fast on calculating the angle measurement. In the next example, because now you've seen it, in the next example I'll take it a little bit slower and show you those steps again. Okay.